Hello, it's Mr. Claudy, and today we're going to continue talking about one variable statistics. And like all lessons in this section, we're actually talking about how we can present or display statistics so that it's easier to understand the data set. For example, let's say I have the following test marks for all the students in my class. If I present them this way, it's not very useful. It's kind of useless. I can't tell you anything to compare this class to another class. We learned in our last lesson that one way I can analyze this data and present it to you is I could use the central values. So I could tell you the average for this class, or the median, or the mode. Now those are nice ways of representing data, but they only give us the middle, whether that be the median or the average or the most frequent. It's a middle value. And I might be more interested in how the data is spread out. So today we're going to be looking at how I can use some different statistics to measure the range of the data. So the first thing we're going to talk about is, let's go back to that idea of the median. Or no, let's go first talk about one statistic that is very easy to calculate, which is the range. The range is just the max value minus the min value. So in this case, the range is 98 minus 27. So that's 72. Believe it or not, that's a useful statistic because that tells me how spread out the data is. If my range of another class is 2, that would be a very different set of data and tell you something very different about how I'm teaching. Now I might be more interested actually in where most of the students end up, right? I could have one really bad student, one really good student who really affects the range. So we're going to learn something today. It's called the interquartile range. Now to get there, first I want to talk about the median. If you remember, the median is the middle value. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I have 22 values. So I want to find the middle value, which is the 11, well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 22, so the middle value, so this is 11, this is 12, the middle is halfway in between. So here it's actually pretty easy to calculate. The median, or the middle value, which we're going to name today something. We're going to name it Q2. If this is the point where 50% of the data is higher, 50% of the data is lower. So 50% of the data is greater, 50% is lower. Now to calculate the median, we already did it sort of. We use the n plus 1 divided by 2 value. So in this case, for Q2, to figure it out, the median, we had, what did I say, 22 data points. So 22 plus 1, 23. 22 plus 1 divided by 2 gives me 23, gives me 11.5 value, so 11 and a half the value, which we just saw is 71, sorry. Because the average of these two is 71, right? Basically the point in between them is still 71. Anyways, that's the median. We've already done the median. That's the middle value. So what we're going to do when we're talking about data ranges is we're actually going to divide, instead of dividing the data in half above, half below, we're going to divide the data into 4 pieces. So I'm going to actually count out, there were 22, so 1, 2, 3, 4, 5. So I want to, and then 1, 2, 3, 4, 5. So I can actually put a divider. I guess the next divider would be halfway between 61 and 65. This will be Q1, which is also called the first quartile. The lower quartile, or the 25th percentile. a lot of different ways of talking about this. Remember, what we're trying to do is divide the data into 4 sections, or four ranges. So we have my first, second, third, and we'll do the fourth. So Q1 is that divider between the lowest quarter and the second lowest quarter. At Q1, 75% of the data is higher. Now, you come across some of this terminology and this idea, you'll come across in different parts of the world. Like one area where you might hear about this is SAT scores. So when you write your standardized test to go into American college system, you'll find out not so much your grade that's important, but your percentile. If you're in the 25th percentile, it means that 75% of the people in that year had a higher score than you. So it's not great. When you have a newborn child, they weigh the baby and they tell you the baby's weight in comparison to other babies. So for example, our baby was in the 50th percentile, which means that they were, for height, I think they're in the 50th percentile. For weight, they're a little bit less. It was like the 40th percentile. So that means that 60% of the children were at that age were heavier than their higher weight than our baby. We call this the first quartile or the lower quartile as well. That's what Q1 stands for. Now, to calculate this point, to calculate what the quartile is, it's very similar to the median. We use the 1/4 n plus 1th value. So let's see how this works. Q1, well, first of all, Q1, we use a quarter. Now it was 22 plus 1, which is 23 divided by 4. That is, if you want to type it in, 23 divided by 4, the 5.75th value. Now, note here, now this time it's 5.75, so it's 3/4 of the way between 61 and 65. But this is important. We don't actually take a weighted average. For any decimal, you just find the average between the two terms. So let's make a little note of that here. For any decimal, average the adjacent terms. So in other words, Q1 then is the average of the 5th and 6th value. So 1, 2, 3, 4, 5, 6. So it would be 61 plus 65 divided by 2. That gives you, well, I can tell you it's 63. It's halfway between the two. So anytime you have a decimal, just take the average of the two. So if you got a 63 on this test, you were in the bottom quartile. Wow, it's a pretty strong class. Okay, now we're going to do the same thing. Remember, we're dividing the data into quarters. So I have 10 data points here. So there's some sort of divider that's happening 1, 2, 3, 4, 5. So somewhere in between these two. This is, as you would have guessed, going to be called Q3, the 3rd quartile. Or the upper quartile. Or the 75th percentile. This means that 25% of the data is higher. Again, think about what this means. Think about why this is useful. If you looked at the income of everybody in different countries, Q3, it might be one thing to look at the average income, but it also might tell you something else if you looked at Q3, which is the point where 25% of the data is higher. If you have a really high Q3, that would mean that the rich are very rich. Whereas if you had a lower Q3, there's less spread out, it might tell you that the money is more evenly distributed. Or if you have the SAT, again, if you get a 99th percentile or 75th percentile, that's a lot higher SAT score. To figure this out, we use the 3/4 of the n plus 1th value. So if I want to find Q3, I take 3/4 times the number of points, which is 22 plus 1. So I end up with 23 times 3, which is 69/4, which is 17.25th value. Again, as we just talked about, anytime you need to take the average of the 17, or so a point between 17 and 18, like a decimal here, I'm just going to average the 17th and 18th points. So this was 82 and 82. Actually, there's no point even averaging. I know Q3 then is going to be 82. It's worth mentioning once again that Q3 is not 17.25. Q3 is the 17.25th value. So I actually have to count 1, 2, 3, 4, 5, 6, 7, 8, 10 to get 17, 18, and then that gives me the actual value. My statistics are all test marks, so my quartiles are all test marks as well. And again, think about what this means. You can tell something about your class. If the third quartile is 82, it actually tells you that a quarter of the students are above 82. So this range, remember we talked about this range of the data telling you the min and the difference between min and max. Well, equally useful might be the range between these quartiles. We call it the IQR. And we calculate by finding Q3 minus Q1. This is the interquartile range. For our example, it would be 82 minus 63, so that would be 19. So the interquartile range is 19, and that is a statistic that tells you how spread out the data is. Interquartile range of 19 versus an interquartile range of 5. Well, it tells you how spread out the middle half of the class is. There's a quarter above, a quarter below, but the middle half, in our case, has a difference of 19%. If I had another class where the IQR was 5, well, it'll tell you that the marks were very, very close together. So these are useful statistics. Average is useful, but also ranges and IQR, interquartile range, is also a useful statistic. There you see a little joke about, oh no, we haven't got to this yet. Okay. So we can calculate a 5 statistical summary to help understand a set of data. We're going to do this in a few days. We're going to get the GDC, and we're going to say to it, tell me the statistics. And it's going to spit out a bunch of things. It's going to spit out the max, the min, the median, the Q1, and the Q3. With those 5 things, the 5 statistical summary, you can figure out a bunch of ranges, which again is useful for us. The max for our data set was 98, the min was 27, the median was 71, Q3 was 63, and Q1 was 63, Q3 was 82. So once we figure these out, which is pretty easy, we can find a bunch of ranges. The other thing that's really nice, and I've highlighted here, the nice thing about these data points is they're resistant to outliers. Even if you have a really, really high mark or really, really low mark, the ranges tend to be resistant. And Q1 and Q3 tend to resist the outliers, not have a huge effect by them. We are going to show some other tools in later lessons. One way that we represent this 5 statistical summary is with what's called a box and whisker plot. Now, we'll talk about more what it is used for, but the box and whisker plot is going to display the spread of the data. So let me get a calculator. The way the box and whisker plot works is we have, I guess the way I do it is I always start by drawing the median. Now in our case, the median was, here I have all the data here, 71. So I guess around here. And then I want to look at where the median sits in relation to the Q1 and Q3. So 71 is actually 9 away from 63, and it's actually 11 away from 82. So it's actually closer to Q1 than it is to Q3. So I'm going to draw this box to represent that. So there's 63, and there's 82. That's Q1 and Q3. Now, when I look at the min number, or the min is 27, well, that's way, way down here. The max is actually 98. It's not very far away. So I'm going to just draw these whiskers to show the min and the max. So there's my labeled box and whisker plot. I'm just going to show you how I graphed it again. This was the minimum. This was the max. This was the median. This was Q3, and this was Q1. We call it a box and whisker plot because we use a box to represent the interquartile range. That is the middle half of the data. And then we use these whiskers to represent the upper quartile and the lower quartile. So all this information from the 5 statistical summary is summarized here. And now we can actually figure out those ranges I was telling you about. IQR is equal to the Q3 minus Q2, which was 82, minus 63, which was 19. And the range itself, we already figured that out, was 98 minus 27. Oh, it was 71. Oh, I made a mistake. Let me go back to the beginning. It's 98 minus 27. Oh boy, it's going to hurt my YouTube channel integrity. This was 71. And you should attempt, this whole time, you should attempt to draw the box and whisker plot to scale. So the box and whisker plot, like the a bar graph, it tells us something about the data. This box and whisker plot tells us about the spread of the data. Well, it tells us a bunch of things. First of all, the spread of the data. We can see here that the middle half of the data is pretty tight. It's like pretty close together. The lower quartile is very spread out. The upper quartile is a lot tighter. We can see the symmetry, if there's any symmetry to the data. So sometimes this might be more symmetrical. We see this is not symmetrical. We would even say that the data is skewed slightly to the right. We can, like as we showed you, find the range and the interquartile range, which are useful metrics for comparing groups. And we could look at then the box plot of another class, and we could make comparisons. So you're going to be doing this well, hopefully if we do our assignment or a project for this chapter. And once you've made a box and whisker plot, we can use it to do some analysis of the data. So for example, from this box plot, what are some things we see? Well, we can see that 50% of the data is between 63 and 82. The lowest quarter of the data is very spread out. Overall, the data is skewed to the right, etc., etc. So you can make inferences and draw conclusion, or explain a little bit how the data looks using your box and whisker plot. Again, it's not just something you show and that's it. You can use it to talk about the data set. One thing we can talk about now, one thing we can talk about now just before we finish is the idea of outliers. Now, outliers we've already talked about, when you can accept and reject them, but we can actually define outliers using this, what we've learned today. We define outliers as 1.5 times IQR above Q3 and 1.5 times the IQR below Q1. That's it's like a hard definition. And sometimes that comes up. IB will actually ask a question. Is this an outlier or not? So IQR times 1.5. In our case, that would be the IQR is 19 times 1.5, which gives me 28.5. So Q3 plus 28.5, which is, what was Q3? 82, so that becomes 110.5. If you're above that, you're an outlier, which definitely makes sense, right? You can't get over 100 on this test, on a test. And if you're below Q1 minus 28.5, which is, the Q1 is 63, so if you're below 34.5, you're also an outlier, right? That's pretty extreme low mark. Values above 110.5 and below 34.5 are outliers. As we said before, sometimes you can explain why an outlier shouldn't be included, but if you can't, if it makes sense and it is a valid outlier, then you would keep it in your data set, but at least we know the definition of what an outlier is. So that is our lesson all about data ranges, box and whisker plots. Oh, maybe now you can appreciate this joke. Different cats and their contempt for humanity. If you had to survey 1,000 of these types of cats, you can see how their contempt is skewed. So, here, most of the cats, 50% of the cats have this amount of hatred for humanity, versus this first cat. There's a real range, right? They really range in their opinion, whereas these are a lot tighter. These cats are all over the place in their opinions, but these cats aren't. You can see these dots here represent the different outliers that actually are off the box and whisker plot. You might see box and whisker plots when you sketch data, or some variety, when you sketch data in a scientific setting. So when you collect a lot of data points, you don't just want to plot one point, you want to plot some sort of range of the data. So this sort of idea of plotting ranges on a graph is something you might see in science, not in math, unfortunately, but in science. Our homework for today is page 270, number 1 to 5. Good luck with that, and we will see you next time.